An NFA is like a DFA, but in some cases it makes displaying a machine much simpler. NFAs allow us to be in multiple states at the same time, which we'll go over in this video. To start off, we have this NFA here. In order to understand it, we'll go through it one step at a time. Now, starting here, as indicated by the start symbol over here, we'll trace our inputs one by one, just to understand how the NFA itself works. Now, for this table down here, we just have our current state, and then the states after the inputs A or the inputs B. Now, since we start at Q0, that's what we'll put first. Here we can see that if we input an A, then we end up going to Q1. So that's our next state here. Now, back to Q0, if we input B, we go to a completely rejected state, which we can see because we have no transition for the input value of B. So we'll just cross out that section. Next, we'll test out an input for one of the states that we could reach, which in this case was Q1. So since we went to Q1, now for input A, we can see that there is no transition for input A at Q1. So we'll just cross that out. For the input of B, however, we actually have two arrows. We have this one that's looping back to itself, and we have this one that's transitioning into Q2. What this essentially means is that we actually go to both of them. Now, if you're experienced with DFAs, you can tell that this is something unique to NFAs, which makes it non-deterministic rather than deterministic, because you can have multiple transitions for the same value. So B will lead us to Q1. So we'll put an arrow here on Q1, and B will also lead us over here to Q2. So we'll leave an arrow here on Q2. Now for the state itself, we'll just write it as a pair of states, which would be Q1, Q2. So now what? We're currently in two states at the same time, and if you want, you can keep track of them like I do with these pointers that tell us which states we're in right now, which kind of help you get the hang of how NFAs work. I'll be using these green arrows to represent our current state. So since we landed in Q1 and Q2, we'll use that as our next state. Now for this arrow over here, we can see that on input A, it goes to Q3. So we'll remove this arrow and it'll go over here to Q3. For this arrow here, on input A, we see that it has nowhere to go. There's no transition with the input A. So we'll just remove it. Therefore, this is our final state. I'll circle it since it's an except state. Now if we reset it so we can go to input B, and we were here, Q1 and Q2. So now for the arrow on Q2, if we input B, we can see that there's no transition for the input B. So we'll just take that away because it can go nowhere. For Q1, however, we know that on input B, it goes back to itself and it goes to Q2. So this arrow will end up staying in the same spot because we do a loop. But at the same time, we'll also add a new arrow over here at Q2. So our final state will be Q1, Q2. Now for the state Q3, you can already tell over here that there are no outgoing transitions. So we already know that this will be empty and this will be empty. And then we're done. These aren't all the possible combinations of states, but these are all of the possible states we can reach. Now just to test this NFA, we can use a string as an example. Here we'll use a string S, which we'll set to A, B, B, A. Is this string accepted? Well, let's just do the inputs one by one. So on input A from Q0, from the start state, we're going to end up going over here to Q1. Now, once we're in Q1, we input this next A. As we can see, we don't have a transition for the input A, and since it's an NFA, this means that it goes to a trap state or a completely rejected state. So this string is not accepted. For our next example, we'll use a new string, S equals A, B, 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 A. We can use the table for this one to make it simpler. So as always, we start off at Q0. After our input A, we end up at Q1. As we mentioned before, whenever we're at Q1, if we input B, it goes to Q1 and Q2. So here we'll have one arrow on Q1 and then another arrow on Q2. And again, we also have this written down. So when we're in Q1 and Q2, if we input B, it goes to Q1 and Q2. So for all of our inputs up here B, they'll just stay in the same spot in Q1 and Q2. Finally, when we get to the value of A, we can see here that for Q1 and Q2, when we input A, we go to Q3. So we'll remove these arrows, and this will be our final state. And since we landed on an accept state, that means this string is accepted. Now, as for this table over here, the best time to make this table is if you're trying to convert an NFA into a DFA, which we made a whole video on as well. Otherwise, you don't really need to make this. It just helps to visualize what is happening with the NFA and what our current states are. I just made it to help you trace through and learn how an NFA works. So one more thing I'll go over quickly in NFAs is the epsilon/empty transition. You may encounter this transition in NFAs, and I'll just give a brief definition before showing it in an example. The epsilon transition essentially works like this. If you enter a state that transitions into another state via epsilon transition, then you enter both states. Now this might sound confusing, but this next example might help explain it for you. Let's say we have this NFA here. We start off at Q0. On input of 1, we end up at Q1. However, since we just entered Q1, and Q1 is actually pointing to another state via epsilon transition, we also enter Q2. Now we're in both states at the same time, and it works just the same as the examples in the previous NFA. This is useful for making OR cases, like in this case. Let these be accept states. We can input 1 and then 1 again, and then that will be an accept state. Or we can input 1 and then 2, and that will be an accept state. Now, technically for this NFA, it doesn't really affect much because I could just erase everything here and do this, so input 1 or 2. But if we're working with more complicated combinations, we could use that as an OR statement. And that's it. Those are NFAs. If you want to know how to convert an NFA into a DFA, you can check out our video on that. Otherwise, leave any questions you may have below. Thanks for watching.